This conference will now be recorded.
Okay, so coming to secondary metabolites, let me just brief you what we had finished and then we'll move on to the next one. So, first is alkaloids. As you know, the term alkaloid means alkali-like. So, they are used to designate basic hydrophilic nitrogen compounds which are physically active. Can anyone tell me the definition of alkaloids? Yes, I want any one of you to tell the definition as we have discussed in previous class.
Alkaloids are organic products of natural or synthetic origin, which are basic in
Okay,
nature and contain
good.
one or more nitrogen atoms, normally of heterocyclic nature, and possesses specific physiological action on human or animal body when used in small quantities.
Okay, perfect. Very good, Amit. Okay. So, and also, I think you're clear with the history. We had discussed some milestones, how alkaloids started getting developed. So, we discussed about the German pharmacist Meissner, then about the isolations of various alkaloids like narcotine, morphine, emetin, quinine, piperin, caffeine, colchicine, cinchona, papaverine, thebaine, etc. in different eras. Next, we also discussed about the physical and chemical properties. We know that most alkaloids are colorless crystalline solids. They have sharp melting points, and whereas some are amorphous in nature, and some like conin, spartan, and nicotine are liquid and volatile in nature. Usually, alkaloids are colorless, whereas there are some exemptions like betadine is red in color, berberin is yellow, salts of sanguinarin are copper red, etc. And we also discussed that they alkaloids occur as free bases and they are soluble in organic, polar, non-polar, and immiscible solvents, whereas the salts of alkaloids are soluble in water. Okay. Next, we also discussed about their chemical natures, that most alkaloids are basic in reaction because of the availability of lone pair of electrons on nitrogen. Okay. And then they are categorized into primary amines, secondary amines, tertiary amines, and quaternary ammonium compounds. And the basic chemical tests are test with Mayer's reagent, there is potassium mercuric iodide, Dragonroff's reagent, potassium bismuth iodide, Wagner's reagent, iodine potassium bismuth iodide, and Hager's reagent, that is picoronelic acid. So these are the basic reagents, and the colors with Mayer reagent, alkaloid gives a cream colored precipitate. With Dragonroff's reagent and Wagner's reagent, it gives a reddish brown precipitate. And with Hager's reagent, it gives a yellow precipitate. Further, we discussed about the isolation and extraction of alkaloids, that is by Stasotto method. We also discussed about direct crystallization from solvent, steam distillation, chromatographic technique, gradient pH technique, and fractional liberation. Next, we discussed about classification of alkaloids. So there is pharmacological classification based on the pharmacological uses. For example, CNS stimulants. Some alkaloids are classified as CNS stimulants, some as analgesics, some as purgatives, etc. Then you have taxonomic classification where they are classified based on the chemotaxonomic characters. Then biosynthetic classification based on the biosynthetic pathway. Okay, like what is a precursor? Maybe amino acids are the precursor. If they start with ornithine, all those are grouped to one particular class. If the biosynthetic pathway starts with lysine, they are grouped into one. So similarly with tyrosine and phenylalanine tryptophan, if they start, they are classified into one particular group. And the last most important one was chemical classification. Basically, there's two types: heterocyclic alkaloid and non-heterocyclic alkaloids. So in that we have 15 different classes like pyrrole, pyrrolidine, pyridine, piperidine, pyrrolizidine, tropane, quinoline, isoquinoline, phenanthrene, aporphin, indole, imidazole, norlupinan, purine, stearin, steroidal, diterpene, and alkylamine or amino alkaloids. Okay, so we have discussed in detail about the ring structure and some examples under each class. Next is uses of alkaloids. We know that they are reserve substances to supply nitrogen. Then they show different mechanisms. They are repetitive, they protect plant raising animals, herbivores, insects. Then also act as a product detoxification mechanism. So we have a check on toxic plant. They all can be growth related factors. And another thing is they are present in conjugation with plant acids like meconic acid, syncotanic acid. So they help in transportation of such acids. And we also discussed about the occurrence and distribution. This is about alkaloids. Is there any doubts in alkaloids?
No, ma'am.
Yes, any doubts in alkaloids so far? Okay, so I think there's a third revision. All of you must be very thorough with this. Next, we had discussed about volatile oils, terpenoids, and triterpenoids. There are three things in your syllabus. Volatile oil is separate, terpenoid you have to study separately, and triterpenoid. Although all these three comes under the same class. So, what is volatile oil? What did we discuss? What is volatile oil? Yes. So all these slides are over. What is volatile oil? How do you classify volatile oil? Yes. Any one of you can answer. Okay, fine. Let us not waste. So volatile oil is nothing but the odorous, volatile principles of plants and animal sources. They are also called as ethereal oils because when exposed to air, they leave nothing. Chemically, you know that they are made up of terpenes and their oxygenated compounds called terpenoids. They are made up of isoprene unit, that is C5H8 unit. And based on the formula, again, it is classified into monoterpene, sesquiterpene, diterpene, etc. Solubility, volatile oil is soluble in alcohol, ether, and lipid solvents, practically insoluble in water. And characteristics, if you see, they are lighter than water, they have good smell, they have high refractive index, most of them are optically active, and these are present in special ducts called schizogenous or lysogenous ducts, and in glandular trichomes also. And they are more confined to families like Labiatae, Rutaceae, Piperaceae. So all drugs with good smell, you can remember its families and write here. And the main method of extraction is by steam distillation. You can also use other methods like solvent extraction, COLE methods, and enfluorage methods. Okay, then you also have something called terpeneless volatile oil, where this has more value in perfume industry. The terpene part is removed, and so that because see, volatile oil, they get denatured easily, they become rancid. So if you remove the terpene part, it is called as terpeneless volatile oil, and this it has more stability. It is used in perfume industry. So for the chemical test, you can just take a thin section, and if you add alcoholic Sudan 3 solution, a red color is obtained. Or to the TS, if you add a tincture alkana, again red color is obtained. Most important in volatile oil is storage. So it has to be stored in well closed, well filled containers away from light and in cool place. Next, coming to different classifications. So we know that they can exist as acyclic terpenoids, which has open chain structure, monocyclic terpenoids, which have one ring structure, bicyclic, which has two rings, tricyclic, which has three rings, etc. And how is the isolation done? Usually, as we have discussed, it is by steam distillation, and further it can be subjected to fractional distillation, so that monoterpene, sesquiterpene, each method can, each of the monoterpene, sesquiterpene, etc. can get separated or isolated out easily. It can also be isolated by physical methods, chemical methods like treating with sodium bisulfite, phenylhydrazine, Tidens reagent, Grignard reagent, etc. And also we can separate it by using chromatographic process. And as we know, uses, since it has got good smell, it is used widely in perfumery, cosmetics, soap, etc., making of soap, incense sticks, food, pharmaceuticals, beverage industry, etc. Medicinally, many of the volatile oil, they are used as antiseptic, carminative, stimulants, diuretic, anthelmintic, analgesic, antirheumatic, etc. So classification based on the terpenoids, that is C5H8 unit, they are classified as monoterpene, sesquiterpene, diterpene, triterpene, tetraterpene, pentaterpene, and polyterpenes. You know the number of isoprene units. This was very thoroughly discussed. You know the molecular formula and examples under each also. So this comes in volatile oil. Next is phenyl propanoid and flavonoids. So phenyl propanoids, they are nothing but a class of organic compounds. They have aromatic ring and a carbon propane tail. These are synthesized by plants with amino acids like phenylalanine and tyrosine. So flavonoids means it's also called as flavone. So any of the non-nitrogenous biological pigments are called as flavonoids. They include anthocyanins, anthoxanthins, etc. They consist of a large group of water-soluble antioxidant compound, which includes anthocyanins, flavonols, flavones, isoflavonoids, etc. Usually these occur as glycosides. They are a part of flavonoid glycosides. See, now I am briefing you all this. Again, I'll be allotting assignment topics. So each one of you can in depth, whichever topic you get in depth, you can cover it. Keep Kokate as a basic book. So whatever is there in Kokate, you should not eliminate. Others you can add extras if you want. And I'll be sending you a link also wherein you can refer some presentations and you can take information from that. After this class, I'll be sending a list. So the list contains your name and the topic allotted to you for assignment. Try to be ready by next Monday. Okay, and then after that, I'll be sending you a empty presentation format also, a PowerPoint presentation format. So based on that, you can actually start making your presentations. In between, I will also present one drug so you can see how exactly. Now, what a blank presentation I've made, it has got the complete template as per the pharmacognostic scheme. So what you can do now is you can start adding information and slowly you can refine it. Clear? Next, I'll be sending you another Word document which has links. So whichever topic you have got, this is specifically for general topics like alkaloid, volatile oil, phenyl propanoid, etc. So those who have got that topic, you can make use of these links to make your presentation. Clear?
Yes, ma'am.
Now, if we have to discuss about the drugs according to a syllabus which comes under phenyl propanoids and flavonoids, so they've given lignan, T, and ruta. Okay, so lignan, it's a chemical component basically. Here we can consider 2 or 3 plants. Now, flaxseed contains more of lignan. Podophyllum hexandrum contains more of lignan, and Phyllanthus neruri contains more of lignan. Now, this nothing to worry. It's been allotted as assignment topic to some of your classmates. So these drugs will be covered there. So you should just remember now, under lignans, you can study flaxseed, podophyllum, and Phyllanthus. So chemical category, they all contain phenyl propanoid. So main constituent is podophyllatoxin, alpha peltatin, beta peltatin, and they are used as laxative and anti-cancer drugs. Next is T. T is obtained from thiacinensis. So basically they contain flavonoids, in that the main constituent is caffeine, quercetin, myrcetin, camphorol. They act as CNS stimulant, diuretic, and antioxidants. And next is ruta, that is ruta graveolens. So this is obtained from it mainly contains a flavonoid called as rutin, quercetin, and soralin. It is used as anti-cancer and anti-inflammatory agent. Okay, so this is the third category of um, secondary metabolites as per your syllabus. Next is steroids, cardiac glycosides, and triterpenoids. So even this we have discussed many times. So glycosides, they are nothing but organic compounds which are obtained from plants, and on enzymatic hydrolysis, they give one or more moieties along with a sugar and a non-sugar moiety. Sugar moiety is called as glycone. Non-sugar moiety is called as a glycone. Next, in glycosides, there are so many types, but since in your syllabus they've just given steroidal glycoside. Steroidal glycoside is nothing but cardiac glycoside. So this consists of any group of glycosides which is used to stimulate the heart, especially in case of heart failure. They are obtained from number of plants like foxglove, digitalis, quill, etc. And steroid triterpenoid saponin is under this you have triterpenoid. So triterpenes we have already discussed in volatile oil. Triterpenoid saponin will come under glycosides. Okay, so it contains saponin compounds. Saponin is nothing but a class of chemical compounds. These are amphipathic glycosides. They produce soap-like foam when you shake it with aqueous solution. So saponin means soap-like. Now these many days we have just discussed individually what is glycosides, what is tannins, what is resin, what is volatile oil, alkaloid, etc. Today whatever I'm telling you is just I'm briefing you based on your syllabus. So under this, you have certain drugs to be studied. So they have given 3 drugs. Now licorice, it's nothing but it's a rhizome obtained from Glycyrrhiza glabra. So it's a triterpenoid. Main constituent is glycyrrhizin and glycyrrhetinic acid. It is used as expectorant. It is used to reduce cough and it's also used in treatment of peptic ulcer. Next is Dioscorea. So Dioscorea is the tubers of Dioscorea deltoida. This also contains a triterpenoid, namely diosine, and its glycone content called as diosgenin. So these are used as precursors for steroidal synthesis. Next is digitalis. This is obtained from leaves of Digitalis purpurea and Digitalis lanata. So this is a cardiac glycoside. Basically, digitoxin is a content and it is used in treatment of congestive heart failure. Okay, so this comes under the second subunit in unit 2. Next, volatile oil we have discussed. So in your syllabus, 5 volatile oils you have to study in detail. That is mentha. Mentha is nothing but whole plant of mentha piperita. It contains volatile oil called as menthol and menthone. So these are basically used as natural pesticide flavoring agent. It is also used in treatment of irritable bowel syndrome. Next is clove. Clove is got from, it's nothing but the flower bud of Syzygium aromaticum or Eugenia caryophyllus. It has volatile oil, namely eugenol. It is used as dental analgesic basically. Next is cinnamon. So it's obtained from the bark of Cinnamomum xylanicum. It has cinnamaldehyde as a main content here. This is also used as carminative, mild astringent, etc. Next is fennel. It is a dried ripe seed from Feniculum vulgare. Main content is anethol and fencone. This is used as carminative. Further, you have coriander, which is obtained from dried ripe seeds of Coriandrum sativum, a family Umbelliferae, and it has linalool, D-linalool or coriandrol as the main volatile oil content, and it is used as carminative flavoring agent and anthelmintic. Okay. So now this in the tabular column, whatever I've made now, made you do now, you have to start writing the drugs and start by hearting like this. Next is tannins. So tannins are nothing but they are naturally occurring complex organic compounds which possess nitrogen-free polyphenol group, and usually these tannins are high molecular weight compounds. Okay, they are high molecular weight compounds. Usually they are yellowish or they are brownish in color and they have a bitter astringent taste. Okay, so astringent taste means I told you astringent is like when you taste pomegranate or amla, whatever taste you feel, na, that is astringent taste. Okay, so tannins are one of the most widely occurring group of natural substance. They are present in different families and they are the secondary metabolites which are present in solution form in cell sap, and they are also present in distinct vacuoles. Now, basically, they are astringents because they are capable of precipitating proteins. So they are used in medicines as mild antiseptics, and they are also used in the treatment of diarrhea and in the treatment of minor hemorrhages, etc. Commercially, if you look at the use of tannins, they are used as in the leather industry basically, where the hides, that is skin of animals, are treated with tannins to prevent the putrefaction. So what is putrefaction? It is a spoilage of leather, that is skin of animals. So now leather goods, if you don't treat it with anything, it will spoil easily. So whatever you have the purses, belt, etc., why it has got so much of stability? because they are treated with tannin. Okay, it will prevent putrefaction. Now, chemically, if we see, tannins are nothing but they contain mixture of complex organic substances wherein polyphenols are present with orthodihydroxy or orthodihydroxy groups on phenyl ring, and they are devoid of nitrogen. Okay, they form colloidal solution when you add water to it, and they are non-crystalline substance. And if you make it as a solution, they show acidic reaction because they have phenols in them. So they are, I told you they form colloidal solution in water, means they are not soluble in water, but they are soluble in alcohol, glycerin, dilute alkalis. But they are also practically insoluble in organic solvents except acetone. So tannins are only soluble in acetone. Some of the specific chemical reactions are they react with gelatin, they react with alkaloids to form precipitate. So they can be given as antidotes. So if somebody has consumed more of alkaloids, if it is acting as a poison, immediately if tannin is given, it will precipitate out the alkaloids. Okay, so it is used as an antidote in case of alkaloidal poisoning. Now tannins, they can also form precipitate when you add salts of copper, salt of tin, salt of lead to it. They also precipitate if strong potassium dichlorate solution or chromic acid solution is added to it. And with ferric chloride, they show color reactions. They give a bluish black color or a brownish green color. And with potassium ferricyanide and ammonia, they give a deep red color. See, you would have seen in certain science exhibitions and all, where they have a knife and they show that they just touch it to the skin and they show the blood is coming out. So this blood is nothing but the knife would be dipped in tannin solution, and then on the skin, if there is potassium ferricyanide and ammonia, if you just touch it, it will give a deep red color. So as fun in exhibitions, usually this is done where they dip the knife in tannin solution, and then again if it is dipped in potassium ferricyanide and ammonia, so they just touch it to the skin, showing that as if the knife is penetrating the skin, you can see a deep red color. This is a color reaction formed by tannins. Next, most important one, the most important one which we have not discussed is the specific test for tannin, that is cold beater skin test. So this is many times asked as a 2-mark question. So gold beater, it's nothing but a prototype of untanned fresh skin of animal. Okay, usually of ox. It's obtained from the intestine of ox. Now this membrane, so what is it? You're going to take the untanned, means you're not going to tan it. You'll just collect the fresh skin from the membrane or from the intestine of ox, and then treat it with hydrochloric acid. Now properly rinse it with distilled water. Then you're going to place it in tannin solution for 5 minutes. Again wash it thoroughly with distilled water and place this in ferrous sulfate solution. So these tannins will show brown or black color on the skin. This is what is done in case of commercial leather industries. So what is done? The untanned fresh skin, that is membrane from intestine of ox, is taken and it is treated with dilute hydrochloric acid. Rinse it with distilled water, then place it in tannin solution for 5 minutes. Wash it again with water, then keep it in ferrous sulfate solution. So you should just remember, collect the skin membrane from the intestine of ox, treat it with hydrochloric acid, wash it with water, place it in tannin for 5 minutes, again wash it with water, then place it in ferrous sulfate. So HCl, tannin, ferrous sulfate, 3 things you should remember. In between everything, you're going to wash it with water. So if tannins are there, it will give brown or black color to the skin. And another last reaction is tannin. If you add 2% solution of phenazone, it will form the tannin solution being prepared with sodium acid phosphate. It is going to show a precipitate. Okay. Next is the gold beater skin test clear?
Yes, ma'am.
Okay. Next is classification. So tannins are classified as hydrolyzable tannins, condensed tannins. Or in general, if you see, usually we have it as true tannins and pseudotannins. Pseudotannin is again false tannin. They are a separate group of tannins, but they are considered a subgroup because They do not obey Goldbeater skin test and they are low molecular weight compounds. Only difference is they do not obey Goldbeater skin test and they are low molecular weight compounds, whereas true tannins are high molecular weight compounds and they obey Goldbeater skin test and they also obey all the features what we have discussed. Okay, so in true tannins we have hydrolyzable tannins and condensed tannins. Hydrolyzable, as the name suggests. So whoever has got tannins for your assignment, no PPT, you can just contact me. I'll just help you out in making it easier. So hydrolyzable tannins means, as the name suggests, it can be hydrolyzed by acids or enzymes to produce gallic acid or ellagic acid, which on further distillation gives pyrogalol. And one more thing is, when you treat it with ferric chloride, they'll give a blue color. Example is myrobalan, eligotannins, clove, etc. So condensed tannins, as the name suggests, they cannot be hydrolyzed. They are non-hydrolyzable tannins. They are also called as phlobartannins or proanthocyanidins. They are related to flavonoid pigments because they are derived from flavones. And when treated with enzymes or mineral acid, they get decomposed into a red color substance called phlobaphene, which is insoluble in water. And if you add ferric chloride to this, it gives a brownish green color. Hydrolyzable tannin gives a blue color. This will give a brownish green color. Okay, example is Coca-Cola, areca seeds, black catechu, pale catechu, etc. So now in this, again, black catechu, pale catechu has been allotted as presentations. So when you study those, you'll get to know what constituent it has and what is its actions. Usually these tannins are present as galls. Galls is nothing but a kind of swelling growth on the tissues of the plant. You would have observed some lumps on the trees. Those are nothing but usually they contain tannins. Okay, so in tannins you have got to study 2 or 3 drugs. One is black catechu, that is acacia. One is pale catechu, Ancaria gambia. So it contains mainly catechin and is used as astringent. Next example is pterocarpus. So pterocarpus marsupium. This has a non-hydrolyzable tannin called as pyrocatechin. It is used as anti-diabetic drug. Okay. Next class of metabolite is resins. So even resins we have discussed in yesterday's class. So what is resin? Where do you find resin, or can you name some drugs which contain resin? Yes. What are resins? Yes, any one of you? You can see the slide also and tell me. No one wants to answer? Shashank?
The complex amorphous
Yes,
product
Chaitra,
which
tell me.
contain essential oils, oxygenated products of terpenes and carboxylic acids, which are
Very good.
so less solid in nature.
Okay, they are usually semi-solids. So resins are amorphous products of complex chemical nature. They usually contain mixture of oil, essential oil, oxygenated product of terpene. What is oxygenated product of terpene called as? Yes.
Terpenoids.
What is a very good terpenoids? So they contain terpenoids, terpenes, essential oils, carboxylic acid, etc. And usually they are found as exudation from the trunk of trees. See, so many trees, if you just take a blade and if you make an incision, something will start oozing out, isn't it? So that is nothing but resin. They are transparent or translucent solids, semi-solids or liquid substance, and they usually contain large number of carbon atoms. Many resins are heavier in water. If you just drop it in water, it is going to settle at the bottom. They are insoluble in water, but they are soluble in alcohol, volatile oil, fixed oil, non-polar organic solvent like benzene, ether, etc. And these resins are hard, electrically non-conductive and combustible masses. And if you heat it, so they are semi-solids, I told you, they soften and they ultimately melt. Next, these are also got in schizogenous and schizolysigenous duct. Which other one we discussed that it was formed in schizogenous and schizolysigenous duct? Which other secondary metabolite was formed in schizogenous or schizolysigenous duct? Yes, I told you the meaning of
Lignin.
schizogenous duct also. Lignins, then something else which is important, which is formed in the gland. Now, what is schizogenous or schizolysigenous?
Gland formed between
Yes.
the two are split between two cells.
Okay. Between two cells, there will be a split, and in this split, a duct will be formed, and there will be secretions in this. So, with respect to which secondary metabolite we had discussed this? Just think of the secondary metabolites. Just think which one is unorganized, then you'll get the answer.
Latex.
Latex, then can I get the answer? Others also can try. Yesterday's class only we had discussed this. No? Where is volatile oil formed? Are you able to recollect now? Yes? Are you able to recollect? Volatile oil is also formed in schizogenous or schizolysigenous ducts. Yes or no? You people can hear me?
Yes, ma'am.
So are you able to recollect in yesterday's class what we had discussed? Yes, ma'am. Okay. Now, coming to classification, okay, chemically, resins may contain organic acids, alcohols, esters, and neutral resins. So, depending upon the resin, we can classify it as acid resin, ester resin, resin alcohol as the main classes. Next, you also have oleo resin. Oleo means what? Volatile oil. So, if resin is in combination with volatile oil, it is called oleo resin. If resin is in combination with gum, it is called gum resin. If it has both oil and gum, it is called as oleogum resin. Next, there is another class called as balsam. Balsam is nothing but a combination of benzoic acid and cinnamic acid. And there is also something called as resins, R-E-S-E-N-E-S. Resins are nothing but complex natural substance. They don't have any chemical property. They are inert chemically. They don't form salt. They don't get hydrolyzed. Some examples are like asafoetida, colophony. These are all resins. Resins means they are neutral substances. Next, coming to isolation of resins. As I told you, oil is there, gum is there. So oil, how you can remove from the plant? How is volatile oil isolated? How is volatile oil isolated?
Steam distillation.
Yes. So if you subject resin to steam distillation, oil portion will come out. Gum, how you can isolate gum? See, if you add hot water to gum, what will happen? Normal gum, you can imagine. If you add hot water, what will happen?
It get dissolved in the water.
it will get dissolved. So if oleogum resin is there, if you want to isolate resin, first thing is you can subject it to steam distillation where the oil will come out. Next, you can add hot water where the gum will come out. We know resin is insoluble in water. So the gum will come out, oil will come out, you will be left with only resins. This is how you can isolate resin. Apart from that, you can also extract it with alcohol and later on precipitate with water, or you can distill, you can heat the plant part, it will become soft and it will come out. Example is guaiacum. Or you can just make incisions like as like resins like asafoetida, myrrh and all. If you just make incision, it will start oozing out. Or it can be collected as fossil resins, or the incrustations can be processed. So these are all the methods of isolation, how resin can be collected. Now in your syllabus there are 6 drugs which you have to study under resin. One is benzoin. Benzoin is nothing but a resin. It's an unorganized drug obtained from Styrax tonkinensis. So it mainly has a chemical constituent coniferyl benzoate, coniferyl cinnamate, etc. And this is used in making agarbatti and all, perfuming and flavoring agent. Next, Google is got from Commiphora mucul. This is the oleo resin, mainly Google sterone and Google sterol is present. It acts as hypolipidemic. It will reduce the lipid levels. Next, the most important one is ginger, which is a rhizome obtained from Zingiber officinale. So this is obtained from it's oleoresin. Main constant is gingerberine and gingerols. It is used as carminative and emetic. Okay, next is asafoetida. This is again unorganized drug obtained from Ferula asafoetida. It is a oleogum resin. That is, it is made up of volatile oil, resin and gum. Main constant is azaresinol and ferulic acid, which is used as carminative and expectorant. Next is myrrh, that is Commiphora molmol. This also has oleogum resin called and certain oxides and enzymes. It is used as antiseptic and astringent. Next is colophony, is got from Pinus palustris. Main, it has alpha, beta, and gamma abatic acids. So this is also used as for preparing ointments, adhesives, etc. Next, glycosides, I think we have discussed again. So according to your syllabus, you have 3 drugs, senna, aloe, and bitter almond to be studied. Senna is nothing but it's the leaflet from Acacia angustifolia. It has mainly anthraquinone glycoside or anthracene glycoside, anoside A and B. It is used as purgative. Aloe is the leaves of Aloe barbadensis and other species. Again, they also have anthraquinone or anthracene glycosides, mainly aloin, barbaloin, etc. They are used as purgatives. Next is bitter almond. Example is Prunus amygdalis. Sorry, the botanical name is Prunus amygdalis. This has cyanogenetic glycoside called as amygdalin. It is used as sedative. Sedative means something which causes sleep, and it's also used as demulcent. The last class of secondary metabolites as per your syllabus is iridoids. So these iridoids are nothing but monoterpenoids. Monoterpenoids we have already discussed. So these are monoterpenoids. Generally, they have a cyclopentano-pyran ring. These are present in many plants and animals. Again, they are C5H8 taken 2 times. That is nothing but terpenes. Iridoids are class of secondary metabolites. They are typically found in plants as glycosides. So iridoids are seen as terpenoid glycosides. They are mostly bound to glucose. You can see the structure of iridoids. So under iridoids, other terpenoids and naphthaquinone. Naphthaquinone is again another chemical class. You have got to study 4 drugs. One is gentian. Gentian is got from Gentiana lutea. So they basically contain iridoids called as phytosterol, gingeric acid, gengesin, etc. And they are used for treating loss of appetite, treating diarrhea, heartburns, etc. Next is artemisia, which is got from Artemisia annua. So this has a iridoid called as artemisinin. It is used as antimalarial. And taxus is got from Taxus baccata and Taxus brevifolia. This also has a iridoid called as taxine or taxol. It's a potent anti-cancer drug. And carotenoids, that is carrot, got from Tachus carota. It has got a tetrotapenoid called as carotenoid. It is used as antioxidant, and mainly it has vitamin A, that is retinol, for vision and for eye. Basically, it is very good for eye. Okay, so these are the drugs. We have discussed taxus, carotenoids, etc. when we were discussing terpenoids only. So this last class, basically again, it is a link to terpenoids, and naphthaquinone is another component which your syllabus suggests. So this is complete introduction to unit 2 of what you are going to study. Now I hope this chapter is clear to you all, except for the individual drugs which we will be starting from the next class. Clear? Any doubts in this chapter? Fine. So after this class, I'll be sharing with you the list, the link, plus the empty format of the PPT. Clear? So according to the drug as per your name, some may get 2 assignments, some whom I really felt they are capable of doing, they can be recognized as advanced learners. I have allotted 2 topics. In case of any confusions, objections, you can call me. Clear?
Yes, ma'am.
Okay, so tomorrow be ready for the test at 11:30. I'll end the session now. Bye-bye. Have a nice day.
Thank you, ma'am.